Welcome back to the channel, guys. So today we'll be focusing on your Electrotechnics N6. We'll be doing your April 2020-2025 paper. So we'll be focusing on your AC theory, which is your question 2. So yeah, let's get into it, guys. So here you are given that a 480 ohms resistor is connected in parallel. So 180 ohms resistor is connected in parallel with a 7.63 microfarad capacitor. So the combination is connected in series with a resistor of 120 ohms and EMF of 250 sine omega t plus 150 sine 3 omega t plus 30 degrees. Voltage is connected across the circuit. The fundamental frequency is 50 Hz. So we are given 2.1 an expression for the instantaneous value of current. So what we are looking for is I, and we know, guys, our I is equals to Im 1 sine your omega t, which we are given here, plus Im3 sine 3 omega t plus your Im3. Here you can say plus your Im1. I forgot to put it here. So this is the kind of approach you are going to take. But now let's go and answer the question. So always when you are dealing with this question, the first thing is to sketch what you are given. So they are saying a 480 ohms resistor is connected in parallel with the capacitor. So a resistor is connected. Here's my resistor connected in parallel. So now let's go in here. What else do they give us? The combination, which means this parallel combination is connected in series with a resistor of 120 ohms. So the connection is connected in series with a resistor, right? And then they gave us our voltage. So our sketch, guys, will look like this. And then here I'll just write the voltage. So this is our voltage here. They're supposed to use a small e, so I'll just use a small e. So E is equals to 250 sine omega t plus 150 sine 3 omega t plus 30. So that is our E, guys. And let me just write it properly. I think the issue, let me just write it properly, guys. So this is what we have. This is what we have, guys. So now let's just fill in our data. So they told us that the resistor is 480. Yeah. So this is 480 ohms. This is 120 ohms. And then our Our capacitor is said it's 7.63 microfarad. So this is what we have, guys, right? So now, okay, they also gave us the frequency. I'll just write it here. They said the frequency is 50 hertz, right? So now, guys, as you can see in the formula I've written here, you have to find IM1 and the maximum current for the third harmonic, right? So how do we find it? That's the question. So the formula says IM1 is equals to the voltage 1 over the impedance. So now, even for I3, it's the same thing. Over Z3. So now, what is our maximum voltage, guys? This is our maximum voltage. Our EM1 is 250. And then our EM2 is this one, guys. M3, right, by the way, it's 150. So now, so the value we don't have, it's the Z. And by the way, how can we get this Z? So that's the question now, right? So guys, to get Z, Z1 will be equal to, remember we have a parallel section here, so it's Z parallel plus Z series. So that is how we are going to get Z1. But remember, guys, you have a fundamental frequency, that's why you have 1 here. And then here we have 3, which is your harmonic 3. So when you are calculating this kind of question, the first thing we must find is, I'll just use a different color. Is your C, the reactance of your capacitor 1, which is 1 over 2 pi FC, right? Then you have 1 here. Here you have 2 pi, our frequency is 50. And then you write your capacitance, which is 7.63 times 10 to the power negative 6, right? And then what's your answer? You'll get 417.8 ohms. So now, guys, remember that I'll just write it here. Our omega is equal to 2 pi frequency, right? So now, another way you could have written this, if you say 2 pi times 50, you are going to get what? 314. Right. So can you say this 2 pi f is the same as in here? So this thing you could have even interpreted it by saying the reactance of the capacitor 1 is equals to 1 over omega times C. And say this is 1 over 314 times 7.36 times 10 to the power negative 6. You are going to get the same answer, which is 117.18. Can you see that, guys? So I just wanted to show you the second method you could have done this. So now, guys, after finding your X C1. Now let's calculate our Z parallel. Our Z parallel, guys, remember, is equals to R times C1 over R plus the reactant of C1. So this is how you're going to get your Z parallel. So now, when you are multiplying, remember that it's in polar form. So in polar form, your resistance is going to be 480 to the angle of 0 times, remember this is a capacitor, so it's going to be 417.18 into an angle of negative 90. If it's an inductor, it's going to be 90, but a capacitor is negative 90. Right, all over, and then here you have R plus XC1, and as you can see, guys, it's an addition. So in addition or subtraction, you must use your rectangular form. So R plus XC1 is equal to, so my rectangular form here is, for R is 480 plus J0, right? And then from my XC is 0 minus, since it's a capacitor, J, and J 417.18. Okay, then you add the two. Then you add them, the j's, you add them together. The first variable you add them, or the first numbers you add them together. So 480 plus 0 is going to give you 480. And then the j's, you're going to get negative j 417.18 ohms. So now guys, just convert this into polar form in your calculator. I trust that you all know how to convert. This is going to be 635.96 to an angle of negative 40.99 ohms. So that is your polar form answer. So now you take this answer, you write it here. This is 635.996 into negative 40.99, right? So now let's just simplify everything so that we'll see what is our ZP. So now you multiply this to 480 multiplied by 417.18. So I'll just write it here, guys. So therefore our ZP is equals to 200,246.4 into an angle of negative 90 over 635.96 to an angle of negative 40.99. So you just divide these two. Remember guys, when you are multiplying, the angles will just add each other, but when you are dividing, the angles will subtract each other. So this number divided by that number, you're going to get the answer that you're going to get is 206.53, right? So when you punch this in your calculator, guys, also just confirm the answer. But I just double checked it now, so the answer you will get here, it's 314.87 over negative 49.01 degrees. And then this is your ohms. And then if you write this in rectangular form, it's 206.53 minus J 237.67. So now remember, guys, now we have our Z parallel, but what we are fighting for is Z1. So we must add the Z parallel plus Z series. So I'll just remove this portion. So now our Z1 is equal to Z parallel plus Z series. Our Z parallel 1 is equal to, since it's addition, you have to write it in rectangular form. It's 206.53 minus J 237.67, right? This one is for Z parallel. So what is our Z series? Our Z series is 120. So this is 120 plus J0. So you add this to 120 plus that number you're going to get is equal to 326.53. And then this number plus 0, you're going to get that number, just negative J 237.67, right? So when you convert this into color form, this is ohms. If you convert it into color form, you will get 403.87 into an angle of negative 36.05 ohms. So this is our Z1, guys. This is how you're supposed to calculate our Z1. So now, remember our goal is to find IM1, that's why you're calculating the Z1, all of those things, right? So now I'll just take this sketch to the other side. I'll just go to a new page now so that let's copy this to the next page. Yes. Now we are calculating what? IM1, which is equal to EM1 over Z1. What is our EM1? Our EM1 is 250, guys. Let me just it's 250, and then what is the angle? As you can see here, it's WT. Since there's no angle, the angle is 0. Here the angle is plus 8. So this is all over. What did we get for that one? If you can go to the previous slide, you will see how that one is 403.87. Okay. So our that one is 403.87 into to the angle of 36.05. Right. So now we divide these two, we will get what? As 0.62 into an angle of, remember, now here you have 0 minus 36.05, because you have 0 minus negative 36.05, so this is going to be positive 36.05. So now this is your IM1. This is your IM1, guys. So now you want IM3. Now we want IM3. So what was the procedure? We calculated first the capacitor, the reactant for the first capacitor. So now let's go and calculate for the third harmonic. Right? So how do we see the third harmonic? This is how we see it. In front of the omega, you are going to have 3. So this means that our x C3 is equals to 1 over this 3. We write this 3 multiplied by 2 pi f times c. There's a shortcut you could have written this, but I'll just show you all the methods. So this is 1 over 3.2. Okay, let me just write that properly. 3 times 2 pi 50, and then you have 7.63 times 10 to the power negative 6, which is your capacitor, right? So when you punch this in a calculator, you are going to get 139.06 ohms. But there is a shorter method we could have written this, and it says that the reactance of the third capacitor of the harmonic is equal to the first divided by this 3. Right? So the answer you're going to get here, the first one was, what was the first one, guys? It was 417.18 divided by 3, and you will get the same answer. So it's up to you guys which one you prefer, but this is how to go about it. I'll just erase this one for space. So now we are going to find, remember, our Z3 is equal to Z parallel 3 plus ZS. Remember, first we were focusing on the fundamental, which is Z parallel 1, now Z parallel 3. How to find Z parallel 3? We may use a different color. How can we find Z parallel 3? Therefore, Z parallel 3 is equal to R times the reactance for the harmonic, for the third harmonic, and then here we know it's just addition. So this is the layout to go around this, and then in polar form R is 480 into 0 times, here's the value here, 139.06 This is a capacitor, guys, so it's negative 90. If it's an inductor, it's going to be 90 over. Now, R plus the third harmonic reactance. You have to find this by using rectangular form. You have to use rectangular form to get this one. So I'll just use a different color here. So R1 plus X C3 is equal to, and what is the resistance for 80 plus J0 plus 0 minus J139.06, right? And then if you add this, you get 480 minus J139.06. Then you convert this into polar form. So when you convert this into polar form, you get 499.74. Guys, I'm rounding off to 2 decimal places. So if you like, you can do it in 3 decimal places. Just make sure all your calculations are consistent. If you are using 2 decimal places, use 2 decimal places all throughout. If it's 3, use it all throughout. So this is our R1 plus the reactance. So just write it here. It's 499.74 all over negative 16.16. Right? So now you multiply these two. You add the angles, you're going to get 66748.8 angle 90 divided by 499.74 into the angle negative 16.16. Right. Now guys, remember the angles they subtract. So here you just divide. So if you divide, your answer will be 133.57. So and then to get the angles, this is negative 90 minus negative 90 minus negative 16.16. You have to subtract here. So this will turn into addition. So now your angle is going to be negative 73.84. So this is our Z paradigm. Right. I'll just erase here for space. You guys, you can just rewind if you want to confirm something. So now we want our Z3. Our Z3 is equal to our Z parallel plus our Z series. And we know that our Z parallel is it's addition, guys. It's Z parallel plus Z series, so you have to go to rectangular form. So what is this in rectangular form? So in rectangular form, guys, this is 37.18 minus J 128.29. So now guys, you just add the two. 37.18 minus J 128.27 plus this resistance series, which is your 120 plus J0. So this would give you 157.18 minus J 128.29, and then you write this in polar form. 202.89 to an angle of negative 39.22 ohms. So now from here, guys, I have to calculate IM3. So I'll just erase this for space, guys. And sorry guys for the noise in my background. Just try and keep up, guys. So I'll also just remove this. So now let me just write our IM3 is equals to IM3 over Z3. So we just substitute now first. So if we want your IM3, it's this one. It's 150. And then the angle, guys, in this case it's not 0. You have it, it's 30. So this is 30 degrees all over 202.89 into an angle of negative 39.22. So now you just have to divide. You'll get 0.74. Then you say 30 minus negative 39.22, which is going to be a minus, and a minus subtracting a negative, it's a positive. So we are going to get 69 point. So guys, it's 69.22. And guys, I do apologize for the noise in the background. I just wanted to shoot this video as soon as possible. So now guys, we have IM3. So the only thing that is left is to write our I. Let me see, I'll just erase this guy because I want to write I here. So our I is equal to IM1 sine omega t plus IM3 sine 3. So now guys, this is 3 omega t plus your angle 3. So just to write this formula, well, let's just say here it's omega t plus angle 1. Yeah. So this is how you write the formula, guys. Then you just substitute everything in. So your I1, you have it here, it's 0.62 sine. And then guys, what is your omega? Your omega is equal to 2 pi f. So you just punch this in your calculator. Remember your f is your frequency, which is 50. And then here you'll get 314. So this is 340 plus, what is your angle? Your angle is this one. So it's 36.05 degrees plus, what is your I3? 0.74 sine. So now here you have 3 times omega, so you just multiply this by 3. You'll get what? 942. So now you write 942t here plus The N is this one, 69.22. So again, guys, this is your I, this is amps. So this was your answer, right? Now let's go and check what was the next question. They are saying here, determine your RMS values for the current and voltage. Okay, let's go and calculate that one first. I'll just go to the page, guys. Okay, I'll just put in a page. Yes. So, what is the formula for your RMS value? For the current, RMS is equals to the square root of IM1 squared over 2 plus IM3 squared over 2. So this is equals to 0. Now this guy is 0.62 squared over 2 plus 0.74 squared over 2. And then this will give you 0.68 amps. So now we are calculating your voltage RMS, which will equal to Im squared over 2 plus Im3 squared over 2. So this is 250 squared over 2 plus 150 squared over 2, which will be equal to 206.16 volts. So yeah, guys, this is where question 2 ends. And again, guys, I'd like to apologize for the noise in the background. I'll make sure next time you have a proper place whereby the background is quiet. And don't forget to subscribe and press on that notification bell so that you will be notified when I update the next videos. Put a comment there on which topics you would like us to cover, and you can send us questions you would want us to do in the following email. So the email is Mr. Shortway Education. This is a single word, guys. It's just a single word at gmail.com. So this is the email, guys. If you want us to send us any question you would like us to do and do a video on it. So yeah, peace.